Hello and welcome back to Room Ravioli. Our next speaker of the day is going to be, well, it's quite clear, so I'm just going to say the name, Craig Kerstiens. I hope I said it well. And he's going to speak about Postgres.
Thanks everyone. So I'm Craig Kerstiens. I work at Heroku, as I was saying earlier, specifically on the Heroku Postgres team. Really quick show of hands. How many people here use Django or have used Django? Okay, what I would expect. How about Postgres? Similar? Okay, a few less at least. So maybe those of you that haven't, I can convince. So really quickly, before we kind of dig in, PSA, if you're on a Mac and you use Homebrew or Mac ports and you've ever had issues with it, in the future if you have issues you may want to look at postgres.app. This is something Heroku's helped create. It's a native Mac installer, so it's like every other Mac application. It just kind of works. You don't have to think about it. And one other is Postgres Weekly. So this is a weekly newsletter that actually I curate with Peter Cooper running the rest of it. With about 5 to 10 links every week on Postgres and how to use it, take advantage of features, that kind of thing. So not really what's going on at the core development level, but how do you as an end user take advantage of Postgres? So really quickly, kind of why Postgres? There's a couple of links here. One is to a talk that I gave earlier in the conference Tuesday, and another is just kind of a blog post. How many people were in that talk on Tuesday or have been in another overview Postgres talk? Okay, so a few. So I may rehash a few things here, but I'll try to get to more of the Django side mostly. But if you've missed any of those, this is kind of the TLDR of why do you use Postgres. It's a pretty rich list, and there's probably a lot of things missing from here. A couple I think of really big things that stand out from other databases. Transactional DDL is really big. Foreign data wrappers. These are absolutely awesome and going to be a big part of the future of Postgres. This is where you can query data from inside Postgres out to like Redis or MongoDB or Oracle or any other data source that you want. There's even ones for like Twitter, which I'm not sure of the point, but you can do it. Extensions are another really great thing where you can add a little bit of extra functionality that sort of ships with core Postgres or maybe doesn't. And we'll highlight a little bit of that. But I think the big thing is really momentum. If you look at every release since probably 8.4, 5 years ago, every release is packed with a lot of new exciting features. And it's really starting to incorporate the best of every other database out there, which is nice. So it's paying good attention to, what's Mongo doing well, what's MySQL doing well, what's Oracle doing well, and starting to pull those in so it can be much more of a data platform. The big problem, though, is this with Django. I'm a big fan of Django. It's great for applications. It comes with a lot of batteries included. But the short of it is it tries to treat all databases the same. It tries to be just as fair to SQLite as it is to MySQL, as it is to Postgres. And that creates certain problems. So, one example of this is data types. In Postgres, you have data types that look like this. So Postgres takes a bit of a different approach. They don't believe that you have to have 5 or 6 data types and push everything into those. You've got just 6 data types for numbers alone. You've got 3 for IP and MAC address, basically working with networking directly in your database. And the nice thing about having these inside your database is it's optimized for it as well. It knows how to index on it well, better than just text and that kind of thing. It's got shapes built in. Even without PostGIS, which is an extension for richer geospatial stuff, you can do basic polygons and calculate distance between those, which is really nice. Now, as I said, it tries to treat all databases the same. So then you have SQLite, which has these data types. And the really confusing part about this is from the SQLite docs to me. I don't understand how null is a data type. I thought it was a value of a data type. So in reality, there's really only 4. And I don't understand how that really maps to that. So you're instantly limiting yourself when you kind of focus on only using the ORM. Even outside of the ORM, if you kind of stick with the bare bones, you've got some limitations. So Postgres, as you might expect, is a pretty rich feature set. With indexes, it has multiple types. So it has btree, gen, gist, knn, spgist. So a variety of index types. South, which is soon getting ported kind of to the core of Django, essentially only supports the btree index. It's just create index. It has no other types of indexes. There's also conditional and functional indexes, which I don't believe South supports. I could be wrong on that though. And the other thing is that South migrations always run in a transaction. Who here is not familiar with create index concurrently? Okay, a few hands. So typically when you add an index, it's going to take a lock on your table, which means you can't write new data. If you've ever done this in certain other databases, I won't name any names, this could take a day to add an index. So you're improving performance, but you're basically taking your application offline for a whole day. Create index concurrently is going to do this in the background. It's going to be about 2 to 3 times slower, but it's not going to hold a lock on your table. And as soon as it's done creating that index, it's going to start using it. So you don't have to take your application online and you can improve performance. But as I said, South doesn't take advantage of it because it can't run in a transaction. So you kind of have to go outside South to take advantage of this, or do it manually in there. And MySQL, well, they have indexes. So this is great, but I kind of want to take advantage of all these cool features of Postgres. So digging in, let's look at a few of them, and then we'll see how we kind of actually use them within Django, of course. The first is arrays. This is probably my second favorite data type and my absolute favorite native data type in Postgres. That's very underused. If you've gone through the Django tutorial and created a basic blog application or ever built a web front store, you usually have categories. This is really common in a lot of applications. You tag things or have categories, and creating an extra table for that just seems like overkill to me. Postgres has native arrays. Just like you would in your application, you can have an array in Postgres, and you can have an array of any data type. So here what I've done is said, I've got tags for my items in my shopping cart. So I can tag these as whatever I want, and then search on them just like you'd expect. And this is all in the same row on the data, but I can still filter, index on it, everything else. I just don't have to have a whole other table for that. So looking at it inside Postgres, it's going to look something like this. If I've got items that you can buy, I've got a Django pony, which is a programming and animal, and I've got a Ruby gem, which is programming and jewelry. And I can filter on that just like you'd expect. In Django, that's a little light, but hopefully everyone can see that well enough. There's a third-party extension you can install. So there you're going to essentially install two things. One is the data type itself, and another is an expression manager, so you can query on it. You don't necessarily need the second one if you're not going to query and filter, but in most cases you're going to do that in your application. And then you're just going to use it down there. You're going to say array field and declare the type of it. In this case, it's a database type of varchar 255. You can do integers. You can do essentially any type you like right in there. So then I can have an item that I'm going to save, and I just pass in an array of tags. Pretty straightforward like you expect. And then when querying it, I have to do something a little special. I have to call this, pass in this SQL expression, and that little @ sign with a greater than sign, that's a SQL specific syntax. So you're just passing in SQL syntax there. Essentially this means that it contains the tag programming. You could say where it contains all of the tags, contains any of the tags. You can get pretty specific there, and you can just look up the Postgres syntax for doing that. But you can pass in any filtering that you'd like there. So extensions. Extensions that I mentioned are kind of this weird middle ground, at least the 17 here. Extensions can ship with core Postgres, but aren't enabled by default. So to turn any of these on, you essentially say create extension hstore in your database, and it's available to you. There's also third-party extensions that you can build and compile and install. And a lot of the foreign data wrappers take this effect. My favorite one, actually, my favorite data type is actually an extension. This is hstore. How many people are here are familiar with and have used hstore? All right. So hstore is a key value store inside your database. So you can pass any kind of random key value you want in there. So it really starts to get schemaless. It's not a full document store. It's not a full JSON document inside your database. But I find most cases, NoSQL is a bit of a loaded word. It means a lot of things to a lot of people. But the thing that really excites me about it is flexibility. You can work really fast. You don't have to define columns ahead of time. You don't have to run migration. Just start inserting a bunch of data and build your application. So hstore lets you do this pretty well. So inside Postgres, you would just say create extension hstore, and then you would declare the data type down there. So your data type is hstore. And then when you insert data, you use this syntax essentially for your key and then your value. One limitation is that it's only strings, but I've found it's still pretty good for flexibility. I can live with that in most cases. And you can pass any new strings right in there. You don't have to define them ahead of time. And then of course, as you would expect, you can use it directly in Django. So another custom package, you're going to install Django hstore. You're going to say my field name data is an hstore dictionary field. And you're going to create this hstore manager so that it kind of knows how to work with it inside the model. It's going to give you a little bit of helper functions to it. And then inserting data, I can create a Django pony. So in this case, in my shopping cart application, I've got customers that rate products. So in this case, I'm going to give the Django pony a rating of 5. And then I'm going to create a regular pony and give it a color. I'm going to give it a pink color and say it's a rating of 4. From here, I can filter on these things. So I can say, give me a pony that contains any color. So I want all colored ponies. Or give me all ponies that contain a rating equal to 5. So I'm filtering on not just on the keys or a key is equal to that value. So the same way you would in normal SQL when you're filtering data, you can do this on that schemaless data that you didn't have to define ahead of time. So as I said, this is easily my favorite data type in Postgres. It's a nice schemaless one. We actually use it in production at Heroku for a lot of systems, and it scales quite well, so you don't have to worry too much about that. You can definitely push it to its limits and take advantage of it. But there are some limitations. It's a key value store. It's only strings. You can't nest things. In Postgres 9.2, there's a native JSON data type. But it has some limitations as well. So doesn't have built-in operators, so you can't search for specific values in the JSON. This gets a lot better in Postgres 9.3, which should be out just around the corner, possibly by end of summer. But you can actually do something with PLV8. How many people here have heard of PLV8? Okay, a few. So PLV8 is a procedural language inside Postgres. It's the full V8 JavaScript engine put inside Postgres. So with JSON, I can insert JSON into my database, and essentially that's it. It'll validate that it's valid JSON, say this is good, it's not incorrect. With PLV8, it's the same V8 engine that's inside Chrome and MongoDB directly inside Postgres. So you can create indexes on JavaScript functions. You can create a JavaScript function that'll execute random arbitrary JavaScript as you pass it in. I wouldn't recommend that, but it comes with CoffeeScript as well. So I mean, it's pretty rich. So you can do a lot of interesting things with it. I think a really interesting use case right now is functional indexes. So when you're indexing on some JavaScript function. And of course, you can use it with Django. You're going to install the JSON field type from the T shop, and you're just going to reference it in your model. There are some warnings with this one. So on GitHub, it's labeled Django JSON field. On the T shop, it's JSON field. There is a Django JSON field on the T shop, which is the wrong one. So that's a bit confusing. As well, it's really for Postgres 9.3 and up. At one point, they supported Postgres 9.2, but they reverted some of that since you couldn't search on data. So as soon as Postgres 9.3 is out, I expect this package will get a good bit of improvement and be much more useful. So queuing. Most of the time when you do queuing inside your database, it looks like this. If you do celery and kombu, it's going to die at some point. Most people then go to Redis or RabbitMQ or something like that for their queuing, which essentially are pub/sub. But Postgres, of course, has this ability as well. It's really a great queue, just don't do polling with it. So Postgres has something called listen notify. Listen notify is the same pub/sub that you would expect. It's just inside the database. So there's a Celery backend that takes advantage of this called trunk. You install trunk, and basically you run a SQL script to build up some tables for it. Or essentially, I believe it's the commands that listen and notify. And then down here, you essentially define your broker URL. So you're going to say this is the URL to your database there. And this actually goes a long way. In production, we run the Ruby equivalent of this. But the Python one would do just fine if it were a Python application. This can work just as well as Redis or RabbitMQ in a production situation. So you don't have to spin up one more tool just to run a good queue. Text search. So in most cases, people look at all of these options as soon as they need it. As soon as you need to search on large text documents, a lot of times, lately it seems to be Elasticsearch. Solr was popular for a little while. Both are good, but as you might expect, Postgres can work great as well. Postgres has built-in full-text search, and it can play well with Django. So in defining it, here's how it's going to look in the SQL. You're still going to want to do a few of these things, even when using it with Django. You're going to probably want to create your index, because Django's not automatically going to do this for you. And you may want to create your procedure that's a trigger there as well. But you're defining a separate field type up there at the top called tsvector. And that's essentially going to track certain of the things that it's going to need to search on. So inside Django, there's a few, I would say, really important things here. Obviously, the package you're going to need to install. It's JORM PG full text. And you're going to define your search index as a field in your model. Then down here in the search manager, you're going to give it a lot of data. This data is going to help it know what to search on, what kind of catalogs it's using. Does it auto-update, or do you update it manually? Basically, you're doing a lot of setup and configuring right there. Of course, this is kind of a one-time thing on your model, and then in your application where you're really using it, it's fairly straightforward. In this case, you can search on where it's an object contains something like documentation and about, or documentation or about, so either or, just like you'd expect. And this is going to take advantage of the Postgres full text search engine underneath the covers, just like you'd expect, so you don't have to think too much about it. So indexes. This doesn't entirely apply to the Django ORM, but I think equally as valuable. So in Postgres, you've got a lot of indexes, as I mentioned. You've got btree, gen, gist, knn, sp, gist. If you're anything like me, when I first looked at this, it was something like this. It was quite confusing. I read on them. I didn't quite understand. I still don't understand what sp, gist is for. After having it explained by Postgres consultants to me probably 20 times, all I hear is it's good for phone numbers. So I guess if you're indexing phone numbers, use it. If you know in a very clear, concise way what it's good for, please come talk to me, because I'd love to hear. But there's a few really basic rules of thumb. It's not too hard to figure out. In most cases, you want a btree. You don't have to think about it. Btree is the default one. When you say create index, it's going to use a btree. 99% of the time, this is what you want. And as I said, you probably want to do create index concurrently there and in all cases. Gen index, a generalized inverted index. So this isn't a perfect rule, but I would say I'm 90% confident in this case. You want to use it with an array or hstore. Anytime you've got multiple values of data in one column, that's kind of the default. Gist, the rough rule of thumb is full text search. Shapes, And then a more narrow case of shapes is PostGIS. So if you're doing anything with Django, gist is the one you want. And again, sometimes gist will outperform gen and vice versa, but these are pretty much the rough rule of thumbs here. Geospatial stuff. If you're doing anything with it, just use GeoDjango. It deserves its own kind of half-hour slot. There's actually a really good slide by Julia at PyCon on it, so you can check out her slides. And I believe the video is up on the PyCon US videos as well. So one thing that I find not nearly enough applications have is a read-only mode. Who here has the ability to flip your site into a completely read-only mode and not write data? 2, okay. Wow, that's surprising. So Lanyard had a really good blog post about this. They migrated completely from MySQL to Postgres with no downtime for users. Now, users couldn't say they're intending an event for about an hour or 2 hours, but it wasn't the site was offline, it was just in read-only mode. This is something that every website should really have. It means you can do things like migrations on your database by just saying, here, this is read-only data, we're not writing new data, and point it at it. Well, you do whatever you want under the covers. This is great not only for if you have database migrations or issues, but also security issues. If you have a security thing and you want to be able to flip it into read-only mode, this is pretty important. So this is a middleware I actually created called Django DB Tools. Essentially what you're going to do right here is install it, put in the middleware, and then say read-only mode equals true. A better way to do this is actually read from an environment variable. So you don't have to deploy new code. You can just flip a bit. If you're running on Heroku, you just change a config bar. If you're running with Chef or Puppet, ideally you can push the same environment variable out. And really this is a great way so you can not have to deploy new code, just change the environment, change what's happening, and then undo it when you're done. And what this is going to do is prevent people from posting data to your site, prevent people from logging in. And actually I'd welcome any pull requests too. I think a goal for this is to have a floating banner saying, hey, you're in read-only mode as well. So right now it's not a perfect experience, but it definitely accomplishes that same goal. All right, so one more thing, and this will be the last time I'll poll you guys. How many people here run connection pooling for your database, like PG Bouncer or PG Pool? Okay, so for everyone that doesn't, your Django requests very possibly are looking something like this. So this is a pretty average application on Heroku, out of the box, stock Django. And if you see right there, there's connection time. And the connection time is about 60 milliseconds. And the rest of the request is maybe 15 to 20 milliseconds. It's very, very common that Django by default gets a connection every single request, does some things, and then releases that. This is really, really bad. You're spending a lot of time doing nothing. PG Bouncer is one option for this, PG Pool. If you don't want to run those, I would actually say there's some perfectly good options built into Django. This is the path that most other frameworks take. It's just a application-side connection pooler. So Django Postgres Pool, JORM EXT Pool, and Django DB Pool. I'd mostly recommend this one just because I know the most about it because we wrote it. Essentially, you install it, you say, here's my engine, and you would do the same for South. Then you can configure how many connections do you want in the pool. Do you want 10 or 20 or something like that? And this is just going to keep a pool of connections, so you don't have to go out and get a new connection every single time. You're going to see much better performance here. It's just a good practice. Most other frameworks do it. Fortunately, this gets a lot better in Django 1.6. So in 1.6, they have persistent connections. So it's not a full pool, but it doesn't have to get a new one every single time. So it's definitely an improvement. And then you have the ability to turn it on, turn it off as well, just like you'd expect in Django. So coming back full circle, Postgres is a really great database with a lot of features. My biggest kind of qualm with the Django community and the guys, and I know them well and talk to them and complain regularly that treating all databases the same, you're a good bit limited. I think they're definitely thinking about this going forward with a lot of the database APIs and how do they make it more pluggable so that you could have a backend that takes more advantage, but we're still probably a ways off from that. So to kind of wrap it up, Postgres, it's a really great database. The Django ORM, it's not so bad. It lets you kind of do some of these things. You just have to do a little bit of extra work. So thanks, and then a special thanks to Andre, who actually a lot of these packages are his, not all, but a lot of them are. So the array, the hstore packages that allow you to take advantage of that. A big thanks to him for creating and contributing. Thank you.
Thank you very much.
Hi, thank you for the good talk. I'm always amazed when I see how many things we miss from Postgres being hidden behind the ORM. But, and I'm not really afraid about getting locked in because I can't see myself going anywhere else.
Sure.
But how do you run tests? I mean, most of the times I'm running tests on SQLite, so because it's
run
fast.
Your tests on Postgres. I think a really good practice is running the exact same thing in development and production. Yeah. If you're familiar with the 12-factor app, if not, check it out, 12factor.net. It's a lot of good best practices for developing service-based, good scalable web applications. And a really key one is that you have parity between development and production. So if you're on Debian, it's pretty easy to install Postgres. If you're on Red Hat, it's pretty easy to install. If you're on a Mac, check out postgres.app. You can run Postgres in memory mode, which definitely cuts down on some of the time of startup. And there's things you can do so it's not slow. SQLite, by running it locally and then running Postgres in production, you're definitely going to introduce bugs at some point along the time. SQLite, a good example here is like, if you say you have a varchar of 50 characters, it'll let you just insert 70 and it won't care. As soon as you would then try to do this in production, you could have a lot of interesting issues. So I would definitely try to get to using both in both places.
Thank you.
Yep.
Great talk, thanks. So I was thinking about listen and notify for a message queue, because currently we use Redis, and then we have the problem that we want to send the ID of a newly created object and do some post-processing on that one.
Yep.
So we fire off the task to Redis before the transaction actually commits, and then the task is faster,
Right.
so it fires before the commit. So the task cannot find the newly created object in certain cases. So I was thinking about, are these notifications, are they included in the transactions? Because then that would solve the problem.
It wouldn't be guaranteed, I believe, but you could. It depends on the backend. I'd have to double check. I think you could definitely make it play a little nicer together. Using it as your queue, it's separate. So the listen notify is your queue, just like it would be in Redis. So if you had something like a lock on the table, it may still have to wait for that, for the object to be created. So I wouldn't say it's a guarantee, but it may give you a little bit of flexibility since your data is all there together, that you have a little bit of safeguards. But I wouldn't think it'd be a perfect magic bullet for solving that problem.
Thank you for your great talk. I've got a little mystery question. Why did you use a GIN index in your TS vector example?
I don't have a good reason. I think it was probably just an old code sample I pulled from, so there may have been a case it was a GIN index. Sometimes GIN and GIST can be swapped interchangeably. GIST oftentimes have a little less performance but smaller disk space, and GIN have better performance but much bigger disk space. To me, usually disk is cheap, but that's also not 100% the case. It really varies on the data and what you're doing with it. So if you really get in deep with those, experiment with the two. And Christoph Pettis has a good post on performance differences between Gen, GIS, and actually MongoDB as well, comparing all those. So if you want, you should be able to find that and dig in pretty easily.
Okay, thanks. Hi, Craig. A very good talk. Thank you about promoting Postgres this way. And I wanted to add one thing about testing with Postgres, because you can actually use also pgtap if you want to do tests inside Postgres. Okay, but that's not from a Django point of view, but more from a Postgres point of view. I was wondering, and this is my question, if you ever used or tried PGQ for queuing.
In a previous life, yes, but it's been a long, long time. So I find, most application developers can be a little wary of it. Most Python developers, does anyone here not use Celery? Okay, a few, but I think Celery is commonly the de facto, or there's a few others that just allow you to control it a little better within your application. But PGQ, if you're doing something really rigorous and hardcore, is a really good option for queuing.
Also because I think it could solve the issue of transactionality requirements that was, I think, raised before.
Yeah, in that case, actually, PGQ might be a good option to investigate.
Okay.
Yeah, I'd have to think through it a little more and hear more on the detail, but I think it could work.
Okay, thank you.
Yeah.
Thank you.
Maybe I'm wrong, but years ago, Postgres has a limitation for doing full text search in on fields that are not plain ASCII.
I believe if it was a limitation years ago, I think it's long been removed.
Okay.
Yep.
Great talk. Because you mentioned scaling and sorry, my question is, how do you handle fault tolerance and massively scaling and replication and things like that? Kind of best practices and from your experience, what seems to work?
Sure. That's kind of a whole other can of worms. So I can talk a little bit to specifically what we do at Heroku. So I mean, when you start talking really, really big data sets, you're looking at sharding. The Django routers are pretty good for that. You can shard in a variety of ways there, and it can work well. At the database level, Postgres has streaming replication. There's a variety of options there. So there's Bucardo, there's Londist, there's actually a tool that we created called Wally, which ships the write-ahead logs. Essentially what you're looking at is a combination of base backups and wall shipping commonly. I believe Bucardo may be multi-master, or...
Oh, yeah, there's multi-master functionality, but there's actually work going on for multi-master.
So multi-master is making some progress. I believe it may
it's
hit
already in
9.4.
production. And it will be, there's actually an open source version written by Second Quadrant, which everyone can download. It's called BDR, bidirectional replication, and it's in production on one of our customers, and we hope it will be in the core of Postgres in 9.4, which is next year.
So
but it's
multi-master,
actually, it's a mix of physical and logical replication. So you can actually inspect wall files and decide which parts of the wall you can actually replicate. You could also use that to replicate to Oracle, for example.
Yeah.
So it's open source. So if you actually look for BDR PostgreSQL, you come up with a patch and with a big user guide. So
for most of those, I wouldn't recommend for the faint of heart. Most of the replication options in Postgres are a good bit of setup. We created Wally to be really, really lightweight. In Postgres 9.3, there's, I think, human readable write-ahead logs. In 9.4, the hope is multi-master. It's never guaranteed until 9.4 is released. And there's also hope of logical replication, which makes upgrading from one Postgres version to the other with no downtime or little downtime much, much better. Today, I'd look at, if you kind of talk to the Postgres community, there's 4 or 5 really options for setting up read replicas and higher availability. And then it's up to you on the application side really for sharding. But the Django routers do make that really easy for you.
You mentioned the array type for categories. Can you join the other way around? So you have category and you want the post. So can you join from that kind of type?
I mean, yeah, you could select like the distinct categories and join out everyone that has that. So I mean, it's just looking at join the other way around. So if you wanted to say, I want all posts that have the Django category, you could easily filter on that easily.
Okay.
Yep.
Anyone else? All right. Thank you very much.
Thank you.
Thanks.
Just